show a quick show of hands right before we start. Has anyone in this room been in one company for 14 years or more? How many years? 30 plus, that's got to be a record.
15 good ones and one really shitty one.
Sorry for the one bad one, but at least but anybody else? Nobody. Okay, so he's number 3 in the room for the longest tenure. Our speaker tonight has been with Attunity for 14 years. He's got a deep background in data replication, and he's now the Director of Solutions Engineering for Attunity. Please welcome Sami Zeitoun.
So it's gonna be hard to follow your part, so apologies. I'm not gonna be that exciting, and I need to figure out how I'm gonna do this. Okay. So first thing is nice to be here. First apology, I'm not gonna be that fun, and the second one. As you can see, English is it's not my first language, so I'm going to be sometimes struggling with words, so bear with me. Actually, I'm going to start my presentation today with a story from yesterday. So it's a real story. I have evidence for it. And so I was walking in 7th Avenue, next to my apartment there, and some guy stopped me in the street, and I have this habit that I can't ignore people, so I stopped and started talking to him. And he was from Greenpeace. He wanted actually to make me a member and sign some kind of monthly donation. So he kind of tried. At first I was like, no, I'm not going to do that here. And he was very aggressive. So he was like, pictures of whales and pictures of, and starting talking about tuna fish, and so it's hard to say no to that. I was like, yeah, I know, I drive a Prius, I'm with the environment, but eventually he said 3 words that got my attention, and that was Gulf of Mexico. Well, actually it was 7 words. It was oil leak in the Gulf of Mexico, so 7 words. And when he said that, I kind of told him, yeah, but you know, I do things for environment. I know what you're talking about. Like in my work, I help environment. Well, I didn't really say that to him. I was like, okay, let's get over with it. But in my mind, I said, yeah, I have an opening speech for tomorrow. And so he ended up with kind of signing me the Greenpeace thing. I got a thank you note from a whale. Greenpeace things. But the opening speech was the important thing, and I'm gonna get to that. Why actually my work, I think I'm contributing to the environment, and especially to that use case. So yeah, that was the welcome and introduction part. And so I'm going to talk a lot actually about big data. When we talk about the IIoT here, it's the industrial Internet of Things. I'm not going to say industrial Internet of Things every time because that kind of make my tongue numb. So I'm going to say IoT, and that's what it is. So a lot about IoT, a lot about big data and how it's related to IoT. We're also going to kind of talk about where Attunity's vision for big data and big data integration for IoT and some use cases and success stories. So, some infographics here. So what we're talking about actually when we say big data. If you look at where we stand right now about the big data, the data in shared right now, so we are actually looking at 40% increase every year going forward. That's actually, if you think about the IT increase or the IT growth, the IT is going to grow in 5%. So you have 40% data, 5% IT. Another thing you can see in this slide is that if you look at 2010, and you look where we stand right now for the amount of data available in the internet, or actually amount of data available and data that needs processing. So we're actually talking about currently 50-fold growth since 2010. That's huge. We're talking about reaching 40 zettabytes by 2020. And that means 5 terabytes per person on Earth in 2020. That's a huge amount of data, and we're just going, like, this is increasing all the time. We have machine data increase. So we have about 30 million sensors now sharing data everywhere. It starts with industrial sensors. We have transportation, and you can see the graph that we're actually doing 30% per year. The machine data growth. What is this data coming from? So there are many sources actually. Some are social sources, your Facebook, your Twitter, your Instagram, the machine data, or your databases, your, let's say, your data centers, your databases, your relational databases, and your mobile phones. They are contributing these kind of amount of data to where we're reaching actually 3.5 zettabytes only on the public net. So if you're looking at, if you remove the data that is currently like limited inside the data center, on the public net you have 3.5 zettabytes. So when we're talking about IoT, we're actually talking about big data. And that was the first 3 slides of the presentation. It's a huge amount of data, and you have many data points, many events supporting this data and contributing to this data. So why does IoT matter, and who is using it? We're basically talking about, so what is IoT? We're talking about a lot of machines, a lot of sensors, communicating between each other through the internet. So if you have your, your app that, on your iPhone you have an app that records your activity when you go running. And then you go back to your PC or your laptop and you see the numbers you did. So it's all connected, whether you have sensors or medical sensors in your body, how do you call it, the UP24 now, all these things are contributing to this big data. So, and what we are talking about is how we are able to access and manage these devices from everywhere. So you can manage everything through the internet. You can always access these utilities. You can activate them. You can check their status. And by doing so, there's a great benefit. We're actually talking about improving the safety of people. If you have a sensor in your car that shows you if the car went out of range and you're giving the car to your kid, you want to know what's going on, so you get alerted. You know actually where your car is. And sometimes it's better than that. Sometimes it's different machines communicating with each other and doing some kind of process that makes your life much easier. And and actually, we can also avoid disasters. So if you have sensors that can monitor the activity of some critical machine or some critical process, you can always, through IoT, through the fact that this machine is connected to the internet, you can monitor its status and see what's going on. Because if you think about it, till now, the communication is between people or between someone and a machine. And now that the machines can also share knowledge, and then you can look at the information after it's being processed from different sources, that gives you a much better understanding of what's going on. So I already talked about this, so where is it used? So we're talking about machines where you can check the status. You can, factories that are currently have processes and flow, management flow, or all the process is actually monitored, and it's more than monitored, it's also manageable through the internet. You're back at home and you can do all these things and not being physically in the factory. So where is the market going with this? So, according to Forrester, it's saying that the market for big data will reach about $12 billion this year. According to Cisco Internet Business Solution Group, they say that 25 billion devices will be connected to the internet by 2015, about 50 billion by 2020. General Electric's similar estimation where they say that the GDP will be increased by $10 to $15 trillion over the next 20 years by using the IoT. So you can see here that it's in all the industries, although you can see that some industries are more affected by that. So I don't know how much you can see of this, but you can see here, this is the gray part here is actually it's the percent of already implemented of the already implementation in IoT. The yellow one is about they are planning to do so. So you have 21% already implementing IoT. So you can see that this is the utilities, oil and gas, and transportation are leader in this, but it's actually cross industry. So just to give you a kind of a sense of what we are talking about when we talk about IoT in these industries. So for example, if we're looking at transportation, you can see that you have the navigation, vehicle navigation, where your car is used to navigate as a GPS. And I use Waze. Does anyone use Waze, the app, social app for navigation? So what Waze does is actually it's sending your data. It's a social navigation thing, but what happens here is that when you collect the information from everyone on the street and they know how fast you're traveling, the process, what Waze does, they process this data and they give you an accurate traffic estimation of when you will hit when you will get to your destination. So that's another use of IoT. If you look at, I don't know, let's say healthcare, so you have remote, the body sensor monitoring. So we already know that you have these sensors that can check your heartbeat, they can check your sugar level in the blood. So all of these sensors are connected to the internet and they are contributing the huge amount of data we're actually dealing with when we talk about IoT. So let's get to the challenges of big data. So we understand that there's a lot of data. Okay, so there's a lot of data. And so what are the challenges here? So the first challenge when you look at this is how you move this data. This is actually that bottleneck usually in these processes. So you have a huge stream of data coming through, and how do you get that? How do you transfer these huge amount of data to the cloud, for example? Because you know the upload rate to the cloud is not something that is very fast. Or if you're trying to, you have many data centers and you're trying to get your data to one data warehouse or a BI database to run your reports, how do you do that? How do you do that efficiently? So the data in the industry, the data can be from your ERP system, from your CRM, from your production databases, from logs for applications, and somehow you need to take all this data from different structure, different types, and put it in one central repository and process it. This shouldn't come as a surprise to anyone that 80% of the work that data scientists put into big data projects is spent on data integration and resolving data quality issues. Because when you have so many sources, and the data in every source is very unique to the source, you will be spending a lot of time trying to figure out how do you compare two sources, the data from two sources, because it's stored differently. Even if you look at the database level, if you look at Oracle versus SQL Server, or you can see those differences. If you have a number in Oracle, good luck trying to find an equivalent SQL Server for it. So you might be close to that, but in many cases you can't really find the exact equivalent. So if the source isn't enough of a problem, you also need to manage it, to transfer this huge amount of data to different targets. So whether it's Hadoop, whether it's on-premise, whether it's the cloud. So when you do that, there are, well, we listed here 5 items that are usually the real pain of doing so. So it takes time. Transferring files, transferring data to the cloud, it takes time. It costs a lot. Manpower and technology. You need, in many cases, you need experts for the source and the target in order to be able to do that. It's usually not real time, so if you're working with batches or something like that, you do it on a daily basis, you do it on a weekly basis, and it's hard to maintain because of the nature of the multiple sources and the multiple targets. It's very hard to maintain. And in many cases, you have multiple installations. You need DBAs involved in all of these installations, and that requires a lot of time and costs a lot. So, what we used to do when you want to transfer data from one place to another is use ETL. For example, if you want, well, ETL is one of the options, especially when you're working with databases. So, did you know that ETL consumes 70% of the data warehouse development time? So if you're trying to build your data warehouse and you have multiple sources, just managing the ETL process is 70% of your time. It requires experts. And if you're talking about moving to the cloud, that's also a thing. That can take a lot of time. So what you usually do is kind of use import-export services. You can do some kind of manual processes to do that. You can actually put it physically on a truck and load it to the cloud, or you can be involved in a lot of scripting and command. And this is the thing, that the longer it takes you to move your data, it becomes irrelevant. So the trick here is the trick is that you need the data fast and in a process that might take a lot of time to do and might be complicated. So there is a better way to do that. And here, just a caveat, I'm going actually to talk about, I come from Attunity, so I'm going to talk about Attunity's vision of doing that process. I'm really gonna try not to mention Attunity's products, although you can see some screenshots on the slides, but I'm using that only to kind of demonstrate what I'm talking about. So this is not, I'm not trying to self-replicate here. Yeah, I'm not trying to. So, the big data. So we're trying actually to move the data in order to give you added value, and we're trying to do that. This is the 5 points we think should be the best practice to implement any tool for moving data from multiple sources, multiple targets. So it should be easy, no coding, no complexity. It should be automated end-to-end, because if you just do half of the job, most of the time will be spent in the other half. It should be fast, high performance. It should be real time, because doing that, doing the replication every day or every week, that the data loses its value. So it should be real time. CDC is change data capture, so it should be a real time change data capture, and shouldn't cost that much, because otherwise, when you're talking about many sources and many targets, multiply a big number, it will be a huge number. So we are going there. The world is going to IoT, and it's becoming more and more part of our life. So the only reason this slide is here is to tell the IT folks here in the crowd, we're going there. Be prepared. That's what it should be. You should start looking at your system and try to figure out how you are getting there. That data integration to achieve the IoT is going to happen. It's happening right now, and it's just increasing. It's just going forward. So we talked about best practices. So replicate, we're actually talking about that it's as easy as 1, 2, 3. And these are the screenshots I mentioned before. So it should be easy to configure, easy to run. You shouldn't be, the fact that the job that we are doing under the software, like what we eventually do is complicated, that doesn't mean that the user should have complicated experience. Because it's a lot of work, it's complicated enough, the user should have a very simple experience doing that. You should be able to monitor what's going on with your data integration, data replication, data movement. So it should be available anywhere you want. You should be able to understand what's going on with your system. You should be able to zoom in and zoom out when you're looking at your problem, because sometimes the environment is so complicated that looking at one piece is not enough. You need to be able to zoom out and see what's going on. So it should give you different levels of monitoring for your data. And it should give you the right technology to do the CDC. So this slide actually is from one of Attunity's replicate technology slides, but you can see that I didn't do any mention of replicate. So what I'm trying to say here is that the traditional CDC, where CDC is actually, when you talk about CDC and data change data capture, it's actually identifying any operations that happen in the source and applying that operation to the target, so you keep the source and target in sync. So traditionally, how CDC works is someone did an insert in your source, you do an insert in the target. Someone did an update in your source, you do an update in the target, and you keep these two sides in sync. That is not enough when you're handling big data, because if you're trying now to replicate a SQL Server, an Oracle on-premise database to Redshift in Amazon, that won't work. You can't do every insert on-premise, run it on Amazon, because that's just the round trip of your operation. That's going to take forever. So this is what we call here TurboStream CDC and the high volume CDC. So what we found out, and this is how we do it, others might have other solutions for that. So what we do with this is that we actually batch the changes. We calculate the changes. We use our own technology to load the changes to the target, and we process them in the target in Redshift. We don't apply everyone. But the whole idea here is that when you implement or when you use CDC technology, that can't be the straightforward solution where you have an insert, you do an insert. You need to be able to figure out different solutions. Non-intrusive, and what I mean by non-intrusive is you shouldn't force the customer or anyone who wants to implement data replication to install components in every single database they want to work with. We're no longer living in a world where you have one source and one target and you do the replication between these two. It's now moving to hundreds of sources, to dozens of targets, and maintaining this kind of installations where you need to install every component of every single node, that will not work. The numbers are not, we're not going in that direction. We need some kind of centralized, maybe multi-centralized installations where you have servers in several places handling different regions or different data centers, but you can't work in a place where for every database or every source and every target you want to replicate, you have an installation of your product. I keep pointing that there. I don't know why I do that. Okay. Performance. I already mentioned that before when I talked about TurboStream CDC. So and this is especially important when you're talking about replicating to the cloud. Because replicating inside the data center, you can somehow manage it. But if you're replicating to the cloud, or if you're replicating between data centers, you don't want that insert traveling over the WAN. So you need to be able to find a way to improve that, whether it's loading the tables in parallel to your target, or doing that, batching different tables. You should also be able to run it securely, where the data is not exposed to everyone when it's transferred over the WAN. And you need to be able to recover any kind of errors you have, because when data is moving, you have disconnection, you have packet loss, you have all kind of things that might happen, and your protocol and your technology should be able to handle that. I think this is the last one for the best practices. You should be able to support a very wide list of sources and targets. So this is just the partial list of what Attunity supports as a source and target. This is definitely not the full list, and not for Attunity and not for every use case. So it starts with, you can see here that basically it's databases, what's mentioned there. So the databases and data warehouses, and you can see that there's no end to that. It's very wide matrix, and you should be able very easily, in a very unified way, to address all the needs of all of this in a simple task, where you handle the complexity. The user shouldn't see that. The user should have a simple life when they do their reputation. So I'm getting now back to my initial story. So I told you that when I talked to that guy, it kind of hit me that, okay, I have my opening story, and the reason for that is this one. It's a success story from Attunity, where the project we worked on was, actually, I think it was a result of regulations after what happened in the Gulf of Mexico, where now the requirement was that you have ships all over the ocean or all over the world, and you can't put experts in every ship to handle every single problem that might happen. That's just not feasible. So the requirement was, we want from every ship, we want to transfer in real time to one central place all the data, all the important data, the sensors, the measurements in the ship, to one centralized place where we can process that, and where our scientists and our experts sit and look at this information and figure out if there's a problem or not. Whether this ship is gonna leak, or this ship is gonna sink, or if there is a real problem. You can't have experts in every ship. So, and the big challenge here is that the ship is in the middle of the sea. There is no, how do you transfer big data from a ship to a centralized place? You go to satellite. Now, transferring data over the satellite is a problem. It's very slow. It's not, things get lost when it goes up and down. So, and this is one of our success stories where sorry about that, with Attunity Replicate, when we used Attunity Replicate and we used our mechanism of transferring the files over WAN and the parallelism and the secure transformation, this is actually was a big success, because what they currently have is that in every ship they have our product installed there, and it transfers and replicates in real time the sensors data and everything they need to one centralized center, and they process the data there. They also can transmit the processed data or anything that they need from that central place back to the ship and make things in sync. So this is just one story where you can imagine the ship here is one of the devices that connected to the internet. So the ship is actually one of the players in the IoT. And ships and the data center, and ships between other communicate, and they kind of make and this is where I thought about, I'm trying to make the world a little bit a better place, because with this technology, what happened or future Gulf of Mexico might be prevented. Might be prevented because in time you will be alerted, and maybe you will be able to react differently and prevent natural disaster or any disaster. Retail industry. This is another use case where IoT is really very widely used. So you have smart trolleys, smart chairs, people counter, where you can manage your your stocks, and you can know if something is missing or something, or you need to have and to change the price according to how much it's being, like according to the demand of the people. So in retail industry, you can see a lot of use of IoT. And another thing, another industry that you can see wide use of IoT is healthcare. You can see from the first paragraph here that the huge amount spent on healthcare in 2012, and that 43% of that is estimated to be as a total waste of everyone's money, just because of bad procedures and that of bad non-sharing of knowledge or making the process a little bit more efficient. So this is one place where it's getting more and more noticed, the use of IoT, where they use of EMR now, and the fact that you can track the patient status and you can track the machine's availability and the machine results. If you think about this whole process, this is what IoT is about. It's about those machines, your laptop, your CT machine, and electric chart of the patient, communicating between each other and giving you, the doctor, a better view of what's going on and what's the best way to handle that, and maybe even decrease the amount of time spent on identifying or treating every problem that you might have. The last paragraph here is according to Wikibon, they estimate that some improvements in that process can add up to $2 billion a year and improve the outcome of patients. So bottom line is, IoT is there, it's everywhere now, and I think that managing your data in the most efficient way is the way to both make the process much more efficient, much faster, and it costs much less, and you can save much money by doing so. Eric. Yeah.
All right, guys, before we move on to QA, we're going to just take a quick pause. First off, I want to give a great big thank you to Sami Zeitoun. And for those of you who came in a little later, we do have two $50 Amazon gift cards. This one fell off today, I'm sure it is in my pocket. And it's not going to stay, someone's going to win it, don't worry. So if anyone wants to win these $50 gift cards, please do put your business card or your information written on anything in that blue bag, which is there. Kind of just pass that around, the blue bag. The bag will go around one more time, and then we'll go around at the end. And let's start with Q&A. Who wants to do the first question? Yes.
So, they're just kind of refine the difference between industrial Internet of Things and the Internet of Things. Because now we hear Internet of Things like connected, like appliances, video game consoles, more of the regular consumer electronics. What is the industrial aspect of that? What do you define?
Yeah, well, here. Well, yeah, I think the way I see it, the Internet of Things is when you're like the daily machines you have are connected to the internet, they interact with each other. The industrial Internet of Things, long thing to say. The industrial Internet of Things, creation of data, different sources of data. So if you think about in the IoT, it's connecting your iPhone to your washing machine. So in the industrial Internet of Things, the way I see it, is more of connecting different sources and different targets, so you can have a better understanding of the flow and the process that's going on in your industry.
More in the back end.
Right. Also, you can think about it when you talk about factories, for example. This is more of this like database perspective. When you talk about factories, so the fact that the pieces in your process, like if it's a factory that it's a car factory, manufacturing. So the fact that all the pieces are actually connected and you can control them from the back and you can monitor the process and you can, if there is a machine that has a problem, you don't physically need to be next to it to know that there's a problem, but you're sitting in your office and you see that report, that's okay. Next question. Yes, right there.
The Kongsberg Maritime,
Yeah.
that case, you mentioned one of the issues was transmitting the data via satellite.
Right.
How did you ultimately, did you transmit it some other way, or did
No,
you
we
overcome
do
that?
go over the satellite, but what we do is we develop technology for transferring the files very efficiently. This is the
Oh, I see.
technology we use to transfer the files, to transfer the data over the WAN. And what we found out is that even for a satellite, that was very sufficient because we just use that technology that we developed. And when we have our data there, we just put it in a file and we use our protocol to transfer it to the satellite and to the other point, and that worked perfectly. They were very happy with the performance we gave.
We have time for just one more question. Okay, well, Sami will be here for other questions, for one-on-one questions. Thank you very much, Sami Zeitoun.
Thank you.
Oh, wait, you got the raffle prize. Hold on. Forgot something. It's just sitting right over there instantly. Did everybody have a chance to put in their cards for the raffle? Everybody, yes? No answers? Could you kindly reach into here and just mix it up a little bit? Okay, now without looking in the other direction, pull out any random card. Read it out loud.
Giovanni De Marinis.
Okay. Okay, we got two cards to give away, so don't go anywhere. Which one's got the card attached? Apparently neither of them. That's one yours. All right. Since you've been so good. Look away though. She can read this one.
Adam Maddie.
Adam, Maddie, are you here?
Adam.
With who? No. Good joke. Okay. All right, we're gonna just reach in, grab one out. Lynn Polos. Oh, congratulations, Lynn. Thank you all for coming.